Hello, and thanks for your interest in i2b2 at Boston University. My name is Bill Adams. I'm the Director for Clinical Research Informatics at within the BU CTSI, the Clinical and Translational Sciences Institute. Today I'm going to be showing you a little bit about i2b2 and doing a brief tutorial on how researchers looking to use electronic health data can do sophisticated analyses themselves. i2b2, first a few words about i2b2. i2b2 stands for Informatics for Integrating Biology with the Bedside. The software is open source software based on the Massachusetts General Hospital Research Patient Data Repository, which is a very large de-identified database used for research for many years and has been repackaged as i2b2 for wide distribution across the country, actually in the world. i2b2 is really a collection of modules or cells which in aggregate constitutes something called the i2b2 hive. And the special qualities of these cells is that they can be interconnected. New cells can be developed and plugged into the i2b2 hive, and users and institutions can choose one or more of the cells to implement locally. At Boston University, we've implemented the Clinical Data Repository, which is a de-identified clinical data repository where we can pull data from multiple electronic systems, de-identify that data, and store it within the clinical data repository. The other special thing about i2b2 is it enforces data being linked to standardized vocabularies so that searching and organization are much easier. And in addition, the same concept from one site can be used in another site to do collaborative research. i2b2 also has some query and analytic tools, of which I'm going to be showing you the web client today for doing quick analyses and exploring clinical data. And finally, and equally importantly, i2b2 is being used and implemented in multiple other translational research centers across the country, opening a pretty important opportunity for collaborative research using electronic health data in multiple settings. Just a little bit about how we've organized i2b2 at Boston University Medical Center. We have two installations. One we call BU i2b2, which is the system I'm going to be showing you in this talk. In this installation, researchers only have access to the repository by a software that can perform aggregate queries. So no researcher can do analyses on single patients. They can only do aggregate data queries. Within this framework, the IRB has approved the creation of the repository for research purposes and has deemed that the research queries, because they're aggregate queries, are not considered to be human subjects research. And in this way, many researchers can access the web client, explore the data without additional IRB approval required. A second implementation allows much wider functionality, and that'll be discussed in a separate talk. This system is called the Massachusetts Health Disparities Repository, or the MHDR. And in this framework, we've used complementary software also as part of the i2b2 product, where within a special research environment, researchers have direct access to patient-level data, still de-identified, but now patient-level data. In this framework, the IRB must approve every project individually, and the software is somewhat different. It's a Java Eclipse software package that can't be accessed simply through a web browser. But for this talk, I'm going to be telling you a little bit more about BU i2b2. And the first thing to know about BU i2b2 is it's accessible only within the intranet, so behind the firewall of the BU MC and BMC networks. Users can go to CTSI1 by clicking either just typing CTSI1 or CTSI1 / web client. And by clicking on that link, users are taken to the login screen. And right now, the majority of our users are BMC usernames and passwords, so that you can use your BMC username and password to log in. If it's a BU password, we can also add those too, but that's separately. And this is a quick look at the BU i2b2 web client. And what you'll quickly see in these different panes are some of the functions that are available to users of the web client. First of all, there's a whole range of clinical ontologies available to users to do research queries. An ontology is really a collection of data elements that have been organized and into categories and are searchable either by hand, by navigating through these trees that can expand, or by searching. A simple example of what we might want to do is, well, I'll show you that in a second actually. The main ontologies that we have are an admissions ontology, where people can look at length of stay and DRGs for hospital admissions for everyone who's come to BMC over the last 7 years. Clinical ontologies, so far we've only created one specialized one around smoking. Users can actually look at tobacco use and pretty easily identify people who are current cigarette users, ever cigarette users, or children especially who are exposed to passive cigarette smoke. Demographics are in the demographics ontology, and users can do queries based on age, gender, race, and potentially religion if it's there. For diagnoses, we use the ICD coding classification, and users can go through this manually, or I'll also show you how you can do a quick query through the search terms. All medications prescribed within the electronic health record are also recorded, so the medication lists are used to populate a drug ontology. And then many of the other terms within our EHR are coded alphabetically because there's so many of them and they're not organized into a standard ontology. But users can search through the Centricity EMR database to find codes that aren't either in some of these other ones. We've also mapped in the other system many of the addresses to census tract, so using the system that I'll talk about in my next lecture, it's possible to do analyses by neighborhoods of residents. We also have an insurance ontology, so users can choose patients insured by different insurance plans, etc. We have a laboratory ontology. We have a list of procedures. And then we also have an important service ontology where users can search through different types of services that patients receive at BMC, from the emergency room to inpatient admission, inpatient observe, and then for outpatients there's a whole variety of different services ranging from primary care visits to specialty visits, and those can be searched for within the outpatient ontology in the service directory. I'm just trying to get this to open up. There we go. Where there's many concepts available here that can be searched for, and one of the most common questions would be among primary care patients. That's people who are receiving general internal medicine services. What would a screening rate be? And to find those patients, you'd go in here, you'd expand the medicine services ontology and go down to general medicine. And this tells you that there's 78,557 patients who have ever had a general medicine service. Each user is allowed to save their queries in folders under their own name. For you as a user, you should only really be able to see your own name and the shared name here to do your queries, save them, and then previous queries here can be dragged into your folder to be saved. And the way that i2b2 actually does its queries is using this query tool framework over here. And it's quite simple actually to pull over concepts from various ontologies and organize them in an OR relationship where you can stack concepts on top of each other, and an AND relationship which goes left to right between groups. So if, for example, I wanted to know how many children within BMC have a diagnosis of sickle cell disease, I would go in here and I would first choose the diagnosis sickle cell and search through the ontologies. And you can see that either individual diagnoses could be pulled over, or a folder that has a number of diagnoses inside of it could be pulled over. And when you pull over a folder, all the concepts within that folder are included. So this would be a way to easily count up the number of patients with sickle cell. And so all I have to do to count up a general number is run number of patients and click OK. And in roughly, I'd say 4 seconds, we've been able to count up the fact that there are 1,262 patients who have ever had a diagnosis made at Boston Medical Center. This is the number of patients, not the number of times the diagnosis was made, and this includes adult and children. If I wanted to then ask the question, based on age today, how many of these people are children, I can easily go to the demographics ontology, expand the age list, and then say, tell me how many of those patients today are 0 to 9 years old or 10 to 17 years old. So this would be a query that says how many people are actually children with sickle cell who have ever had a diagnosis made at Boston Medical. And this query was quite a bit, quite equally fast, around 4 seconds, and we could count up that there are about 313 children now, as of today, who have sickle cell anemia and have been seen at BMC. So you can pretty quickly see the possibility here for assessing potential cohorts for research projects, doing some preparatory to research work, how many people, how many visits of a certain during a certain interval. You can refine your query by counting up the number of times that something occurred and also specifying a date range so that this diagnosis was made between certain dates. And then you can also include an exclude criteria, which would say include these but don't include these. And so you can create exclusionary criteria as well. And in this way, you can model some fairly complex queries as a thoughtful researcher yourself by dragging and dropping and organizing your queries. So I'm gonna well, actually that's the main thing. And then after you have done your queries, if you like them and you want to keep them, you can drag them over and put them into your folder and save them to be rerun in the future. And then if you want to rerun this query, just drag it back over and pop it in here, and it will reload your existing queries and you can run it again. So that concludes my brief introduction to i2b2. I think the best way to learn how to use this tool is to actually get an account and play with it. We remain available to answer questions and help out. And our hope is that more and more users will gain experience with the incredible data resources available within these data systems. Currently we have data back to 2000 for BMC, and we have over 1 million patients in i2b2, BU i2b2, and almost 700 million facts or individual data elements about these patients that can be assessed through various ontologies.